Raster versus vector. What's the real difference in GIS? Ever wonder why some maps look pixelated, while others have crisp lines and clickable features? In GIS, all spatial data falls into two powerful formats, raster and vector. They serve different purposes, represent different types of data, and each has unique strengths. So today, let's break down what they are, how they work, and when to use which. Let's start with raster. Raster data is made up of a grid of tiny squares called pixels. Each pixel holds a value, and together these values paint a surface. It's just like a digital photo, but instead of color, pixels can store values like elevation, temperature, vegetation index. Now here's the key idea. Raster is ideal for continuous data. Because continuous data flows, it doesn't jump from one value to another instantly. Think about temperature or elevation. They change gradually across space. Raster captures these natural transitions. Not just where something is, but how it changes. So when you're analyzing patterns or satellite imagery, raster is your best friend. But remember, resolution matters, and it requires more storage and computing power. Now let's talk about vector data, the other half of GIS. Vector data represents the world using geometries, points, lines, polygons. These are discrete features, objects with clear boundaries and identities. Vector data stores not just geometry but also attributes, making it ideal for analysis. The best part: vector doesn't lose clarity when you zoom in. So let's compare. Use raster for satellite imagery, environmental data, and anything that changes gradually. Use vector for infrastructure mapping, administrative boundaries, or any feature you can click and analyze. So remember, raster is for surfaces and gradients. Vector is for objects and features. Can you convert between them? Yes, but conversions come with trade-offs. Next time you work in GIS, ask yourself, am I looking at a continuous surface or a discrete feature?